Hello, my marvelous mathematicians. This instruction will be a review of linear equations. There are several forms we will be utilizing. 1, point slope, 2, slope intercept, and 3, standard. These are all interchangeable and they are all can represent the same line. They are just different forms of that line. One of the other things we want to remember is that when we have a horizontal line, let's say that's our axis, and let's say this is our line. And let's say that that's at the y value of 2, then that is an equation y equals 2. When we have a line that is vertical, let's say that's at x equals 2, then our line would be x equals 2. The slope of this line is 0. The slope of this line is undefined. Okay. Make sure you have this written in your notes, and we're going to go on and calculate slope. All right, let's take a look at the slope. The slope in the past we know has been rise over run. It's the change in our y values over the change in our x values. It's also been referred to as the average rate of change. Moving forward, we will also hear the words just rate of change. The rate of change will be used in the future to refer to the slope at a particular place along a curve. And we'll learn a little bit more of that in the following sections. For right now, let's just review slope. Our formula for slope is y2 minus y1 over x2 minus x1. In the past, the x and y values, which are 1 and 2, have not made such a big difference. But as we move forward in mathematics, it will be very important that you do that, because later on they will take on a direction, and it will be important which is our y1 and our y2 and which one is our x1 and our x2 value. So just get in the habit of labeling and calculating that now. Also, you're going to hear that this slope is also referred to as the change in y, or we call it delta y over delta x. And you'll see that notation more as we move forward. All right, let's just take a quick look at two examples. We have 3, 4 as a point, and we have 3, 1 as a point. If you notice that the 3's are the same, then you would already know the equation and the slope of this particular line. But let's go ahead and use the formula. So we're going to say this is our x sub 1, our y sub 1, our x sub 2, and our y sub 2. So we would have y sub 2, which is 1 minus 4 over 3 minus 3, which would give us negative 3 over 0. Well, you know, in the earlier section we talked about restrictions of the domain. You cannot divide by 0. It's undefined. So the slope is undefined. And we know because both of the x values are 3, our equation is x equals 3. All right, see if you can follow through with this next example then in that same vein. All right, so we have a negative 1, 2. And we have a 2, 2 as our ordered pair. And remember, at any time you need to pause this video and write down stuff, please do so. All right, so at this point, we would again say y2, which is 2 minus 2, and x2, which is 2 minus a negative, which would be plus 1, would give us 0 over 3. Well, 0 divided by 3 is a 0 slope, so our slope is 0. And you should know by now, when the slope is undefined, it's a vertical line, and when the slope is 0, it's a horizontal line. And so if you notice that the y values were the same right off the bat, you would have known this was a y equals 2 equation, and a y graph would be a horizontal line with a slope of 0. All right, that's just a little bit of a refresher. All right, now we're going to use 2 points. I've already labeled them, our x1 and y1s and x2 and y2s, and we're going to find the equation of a line of this particular or the equation given these 2 points. To find the equation, we need 2 things. We need a point and a slope. We have 2 points, so we're going to be able to pick one. I'm going to go ahead and choose that now. I'm just going to pick the first one as my point. So in a minute, my point will be 3, 1. My slope, I'm going to have to calculate. So my slope will be y2, which is negative 2, minus 1 over x2, which is 1 minus 3, which gives me a negative 3 over a negative 2, which computes to 3 halves. That's my slope. So my slope is 3 halves. Now I'm going to use, I'm going to start with a point slope form, and then I'm going to change that into both the standard and the slope intercept form from there. Part of what we do in math as we move higher up is be able to manipulate things. So let's start with point slope, which is the easiest form. So we're going to go y minus our y value, which is 1, equals our slope times our x value, so times x minus our x value of 3. Okay, there is our point slope form. If we want to switch to either y-intercept or standard form, we are going to do one thing. We're going to go ahead and divide this over here. Instead of distributing, if you have a fraction, this will eliminate the need to find common denominators in things. This will simplify your math because you will not be using a calculator. So when I do that, here's what happens. I'm going to get y minus 1 over x minus 3 equals the slope of 3 halves. From here, I can go to slope-intercept form, or I can go to standard form. If I'm going to go to slope-intercept form, I know that's y equals, so I'm going to start with cross-multiplying toward the y first. So 2 times y would be 2y, 2 times negative 1 is negative 2, equals, cross-multiply the other way, would be 3x minus 9. All right, and then I'm just going to simplify this. I would subtract the 2, or actually add the 2, and get 2y equals 3x minus 7. And then, of course, I would divide everything by 2 and end up with y equals 3 halves x minus 7 halves. And that would be y equals mx plus b, our slope-intercept form. If I were going to do standard form, then I know that's ax plus by equals c. I'm going to cross multiply to x first. So I would have 3x minus 9 equals the other way, which is 2y, 2y minus 2. And then I just need my x's and y's on the same side. So I'd move this here and I'd move the 9 over. When I do, I would get 3x minus 2y equals positive 7, and that would be my standard form. All right, feel free to pause and write down whatever you need, but you're going to want these examples. Okay, today we're going to talk about parallel versus perpendicular lines. Parallel lines, of course, have the same slope. They move, their slope is exactly the same, so they run side by side. Perpendicular lines have opposite reciprocal slopes. That means the signs are opposite. One is positive, one is negative, and reciprocal, of course, means it's flipped upside down. The slope is upside down. So instead of 2/3, it's 3 halves. But one would be positive and one would be negative. I think you know that. Let's just take an example here to refresh our memories. We've been given a line in standard form, 2x minus 3y equals 5. We've been asked to find a parallel and a perpendicular line to this line that passes through this point to -1. So remember a while ago, we needed two things. We need a point and a slope. Well, our point is going to be to -1. We already have that. What we need to do is concentrate on finding a slope. Well, the first thing we need to do, since it is going to be parallel to this line, then the slope of this line would be the same for the parallel line. If it's going to be perpendicular to this line, then the slope would be the opposite reciprocal of the slope of this line. So, that being said, I'm sure you've guessed we need to find the slope of this line. Let's just go ahead and solve for y and put it in slope-intercept form, and our slope will be obvious to us. So if I do that, I would move the 2x over, and I'd have a -3y equal to -2x plus 5. I would divide by -3, divide by -3, divide by -3. And all of a sudden, I would yield y equals -2 over -3 is positive 2/3 x, and then it would be minus 5/3. But we're concentrating on the slope. So for our parallel line, we will use this point and 2/3. And for our perpendicular line, we'll use this point and -3 halves. And then we're going to go through the same exercise we went through a while ago. So let's start with point slope form for parallel and perpendicular. So for parallel, we would have y, and since it's minus, it'll be plus a negative, so it'll be +1 equals our slope for parallel, which is 2/3 times x minus 2. For our perpendicular, it would be y plus 1, but our slope would be negative 3/2 x minus 2. And then from there, it's just math. So we'll go ahead and move this over like we said before, and let's end up with slope-intercept form this time. So when we do that, we will have y plus 1 over x minus 2 equals 2/3. And over here, we'll have y plus 1 over x minus 2 equals negative 3/2. We'll go ahead and cross multiply. So 3 times y is 3y plus 3 equals 2x minus 4. And then we'll clean everything up, and when we do, we would get y equaled 2/3 x minus 7/3. That would be a line parallel going through that point. And over here, we would cross multiply, and we would get 2y plus 2 equals negative 3x plus 6. And we would clean everything up and get y equals negative 3/2 x minus 2. And that would be our line perpendicular. All right, pause, take your notes, and go Bearcats. Good luck on your quiz tomorrow.